Hi everyone, welcome to CIIT Peru. My name is Michelle Ash, I'm the CEO of GEOVIA and I'm also the chair of GMG, and I'm very excited to be able to be speaking with you today. I'm just disappointed that I'm not able to join you this year in Peru, but I'm hoping very, very soon. What I wanted to talk to you about today is building the mining virtual twin experience. And I really wanted to share with you why I think it is so important as an industry that we develop virtual twins and especially virtual twin experiences of mines, mining, and of things especially that we want to change and advance in mining in order for us to rapidly increase our rate of innovation and to drive down the risk of those innovations. So I know that I've spoken to you a few times about this particular topic, which is about our role as leaders, both within the industry and leaders of our teams, to prepare not only ourselves, but our teams for an accelerating rate of change in the world. And I think this is as important today as it was, I think it was 2 years ago when I spoke to you last about this particular topic. In fact, if anything, it's got more important, because what we see around ourselves is an ever-increasing rate of change, more pressure on mining to make changes, to become more sustainable, to become more technology-enabled, to become the industry that I know all of you would like it to become more efficient, more effective, closer to governments, closer to communities, and have the presence that we should have and the significant contribution that we should have, not only to the development of countries, but I think there's also a wonderful opportunity for us at the moment to take a leading role in the energy switching that is happening, in the circular economy changes that are happening in the world around us. And, I just look to even some of the energy changes that I've seen in Latin America, such great advancements and developments being done in Chile and the rest of Latam, especially in hydrogen, and especially in green hydrogen, which I think could actually radically change not just mining, but the metals industry. I see great advances in solar and wind energy, again, in Chile and Argentina, in other Latin American countries, but, of course, also in countries like Australia. I recently actually saw in the paper in Australia that over the last 5 years, we've gone from 5% of our energy being solar generated to 17%. Now that is a massive change in terms of how rapidly it's happening. I see more and more consortiums around the world looking at battery electric vehicles, or in fact, consortiums looking at the whole issue of an electric mine. And I think, again, these are fantastic initiatives. And I think for all of that good work and all of those changes, we still have challenges. We have challenges with convincing boards to make investments. We still have challenges with convincing our team members that we need to make changes. Now I'm talking about more broader changes, not just those related to energy switching. I think we'll have challenges even within the full logistics chain in order to describe the benefits of more circular economy, and especially as an industry, as we move from being what is effectively the mining, and I'm hoping the sustainable mining industry, to the sustainable materials industry, and really starting to think more about our role, not only in freshly mined material, but potentially in recycled, in urban mining, and in other ways that we can think about circularity and our contribution in that sense to the continual recycling, reuse of many of the metals that we're interested in. So part of that is for us as leaders to engage in these conversations, to think about these sorts of concepts, to discuss them with our teams, with our boards, with our communities, and to get people used to that level of change. And I think in part that will help drive this rapid change that we need to deliver. But I think also it's about having the tools available to us in order to de-risk these sorts of changes, to drive down the costs of these sorts of changes. Now, some of those tools we have already, and others we have to start developing. And I think, you know, for me, using the virtual mine experience not only allows us to do things in a virtual world before we do them in the real world, but it also allows us to collaborate. Because as we've seen as an industry, one of the benefits, I guess, that COVID has driven for us is it's forced us to reconsider things like remote working. It's forced us to then work through how do we get collaboration. And now that we're not bounded by people having to be at a site, can we actually bring people in from Canada, Australia, Peru, Chile simultaneously to work simultaneously on problems? And does that give us a greater wealth of insight? And certainly my experience in running the GMG is that it does. It gives us, or chairing the GMG, but it gives us some fantastic insights using the collective, now worldwide, knowledge. And all of these things are possible using more and more virtual tools. And I'll come back to it, but I think the word experience is also very important, because again, the way we create a more accelerating rate of change, the way we create more rapid adoption is not only by de-risking, being able to do things in the virtual world before we do them in the real world, but also that the ability to communicate. And I think one of the challenges we've all faced when we've had to communicate complex topics, whether it be to boards or communities or governments, or, you know, even when a geologist tries to explain to me, a mining engineer, about the ore body, it is always a lot easier when you have a three-dimensional picture, and especially one that you can move around, manipulate, you can slice up, you can put together. So you can actually create an experience where people collectively share that knowledge, share that experience. So again, you know, how much more can we do to bring in our communities, bring in our governments, bring in others to help us co-design that maybe haven't in the past, in ways using pictures or videos virtually that allows them to not only understand the problem, and us all to understand the problem collectively, but also contribute collectively. So this is really just to demonstrate. Now, I know I gave you a number of examples in terms of energy switching, which I think is fascinating at the moment. But, you know, underlying digital technologies has also changed rapidly in the mining industry over the last, you know, several decades. We've had a couple of inflection points, one in 2000, you know, driven, I think, not only by the rapid increase in the capability of computing systems, but also the beginnings of some of the good communication systems that we now enjoy. But again, in the 2020s, again, a rapid change, I think driven by two things. One, the declining cost of communication systems and the improvement in the capability. So, you know, nowadays you don't have to rely on using leaky feeders underground. You can put a combination of Wi-Fi and LAN networks and 5G, 4G networks to get high-speed communications all the way to the face. And, you know, it's amazing what then gets opened up and what you can see and what capabilities you have and what capabilities you can unleash in your teams when you have that sort of capability. And, you know, no longer does it cost, you know, multi-millions of dollars to put those sort of systems in. Those prices are coming down rapidly. So we've had another inflection point, and potentially looking towards, and the second part of that inflection point, of course, was COVID and forcing us to reconsider the way we work, reconsider who needs to be on sites at the coalface. How do we get expertise into those areas, solving those problems when we don't have necessarily the luxury we had before of having people so intimately working together. And I think there's been, again, huge changes in the way we go about doing those things this year. So there's a number of technologies that underpin all of this conversation, and I know we've spoken about these a number of times before, but the base of that is a high-speed communication system. And I think more and more high-speed communications all the way to the face are actually table stakes for many mining companies in order to understand what their equipment is doing, what their people are doing, how the plan is going, in order to, in real time, alter the plan as things, disrupt or don't go to plan. As I said, the costs of these coming down quite dramatically. But that really is becoming the table stakes, as is sensor technology and the ability to understand, to be able to see, to be able to hear, to be able to feel, all remotely with the use of sensor technologies, whether that be, geomechanics arrays, something that we've been used to for some time, or whether that be devices on equipment, in order to really understand how that equipment is progressing and going. I think always one of the challenges, and we'll come back to this, is using our wisdom, our collective thoughts, our engineering skills to decide how many sensors we need. So how do we get big data capabilities out of the smallest possible data? And I know a number of us have spoken about this before in terms of, collection of data, storage of data, moving data, the calculations of using data. They come at a cost. Even though that price is coming down rapidly, and certainly using cloud computing and cloud services has dramatically reduced that cost. Not only do you not need people on sites to maintain and to do a lot of the IT background, those people can be in cities, they can be working in teams, but also the cost of servers, the cost of requiring extra computing power, all of that has changed with cloud computing, and certainly the encryption services, the cybersecurity, certainly first class with many of the providers. But I think, being thoughtful about what sensors we need does become a very important part of the equation, because of course, every time we add a sensor, we add maintenance activity, we add cost, we add weight. If you're going to rely on that sensor, you have to make sure it's working. Otherwise, people stop relying on that information. So, it's, again, something we need to think about. Video image and video analytics, both using imagery now with 5G coming on, or in fact even Wi-Fi 6, very exciting capabilities with a lot of the imaging technology that we now have, and everything from LiDAR through to camera technology through to other interesting technologies that are starting to appear. And the ability to then analyse that data using computer vision, etc. Again, creating some very exciting options to provide people with information, data, and better decision making. And of course, the appearance of robotics, of automated equipment, the ability to do things remotely, let alone things like cognitive and spatial computing, all underpinning some of these use cases, as well as some of the capabilities that we can now bring. So coming back to the virtual twin, and one of the things that I was saying that's so exciting about having virtual twins, and working in an organisation now that has brought to the world things such as a virtual heart, where now doctors can learn, can develop capabilities, or medical aids, etc. Very, very rapidly, because rather than having to test out either on real hearts, cadavers and things which precious, and so should be used, only where we have to, or even sort of trialing in animal or human patients. So much can be done now in the virtual world to really make sure that the skills are honed, that the ideas are well formed and tested, that they can even be, approved by various government bodies, etc. So there's, and as I said, numerous people can be working on that same topic simultaneously around the world together. So I wanted to show you an example of how a virtual twin can help explain to people what changes might look like, help you collaborate. And in fact, you can even use AR and VR tools to not only co-design, co-create, look at different aspects in order to, again, deliver rapid change. So I'm sorry, but this video, in fact, doesn't have a voiceover, so you'll be listening to me talk over the video in order to explain what's happening. So initially, this is really a demonstration of how relatively fast you can set some of these up and how you can load in different data. So this particular example, there were different data sets, whether that be from flyovers, whether that be from LiDARs. In this particular case, there was some aspects that were designed or scanned in. But really what they're trying to do is bring in all the data sets possible. So various mapping techniques, in this case, trying to combine virtual and pictorial data, allows somebody to then get a sense of, well, what is this thing going to look like when it's designed, when it's built? For those of you that spent some time in Singapore, you'll be able to identify a number of the sort of major landmarks. You can also bring people into the experience. In this case, the cars are not running, but you could be having people actually walking, driving through this particular simulation and seeing how it's going to interact. So, in a mining case, this might be looking at redesigning roads or traffic systems and having a look at how it might be from a truck's perspective, from a light vehicle's perspective. In this particular part, they're looking at how different changes or aspects will change with different climatic conditions, different light conditions. Here there's some examples of people designing simultaneously, in this case, part of the rail system that they were looking to design and change, and really doing it quite rapidly. And again, you can run simulations through this. Okay, so we're doing this particular co-design. We wanted the rail system running through here. What will that mean for, impact on sewer systems, impact on other transport systems, impact on water systems? What will happen if it's a particular light conditions, water shedding, etc. Again, here we've got an example where you can bring in all sorts of different data. In this particular case, it's data from different hospitals or doctor surgeries, or it could be people saying that there's certain maintenance required, but bringing in both user data as well as data and information from other public sources. Again, in a mining company, this could be using communities to give feedback on dust conditions or where water might be shedding. And then, as I said, a part of this is also how do you get teams of people to co-design? Now, in this particular case, people were all in the same room. But again, all of these people could have been separate and around the world. They're currently looking at the impacts of some of their changes as they're moving things around on sun radiation, on cloud cover, and again, allows you to involve people in a design process that traditionally maybe we wouldn't have included because of the way we go about those processes. So I think just one example of how virtual twins can really be used to collaborate, to bring people together, and to do some co-design. And again, rapidly increasing the rate at which we can innovate. As I said, one of the fantastic things about where we are as an industry is that we have started to digitise. There are so many of these, this computing power available and these capabilities available. Really, it's now up to us as to how do we now apply these in our use cases, in our organisations, to improve our own processes, to improve our planning processes. And one of the things I always remember, and I think I've told this story a few times to different parts of the industry, but I think this issue of co-designing with our communities is so important. And I think we don't do it because there's a big technical divide, between when we're designing mines, or we're looking at those plans, or we're looking at our strategic plan. But one of the things that always surprised me was how much knowledge there is in the community about aspects that could be important to us. So for example, when I was working in Laos, one time we were evacuated because we'd had 200-year floods. And we, so our airport or tarmac was underwater. In fact, even our water system was underwater. So one of the reasons why we had to evacuate people was because, we had limited food, we now had no water, there was poor sanitation because, of course, a lot of the water had risen. So we were evacuating people. But as we were flying, so we used choppers in order to evacuate people. But as we were flying from the mine site to the capital city, one of the things that became very noticeable is that none of the villages, neither their infrastructure, their water systems, nor their food growing areas were underwater, even though this was an unusual event, 2 in 100-year flood. And it, made me think that maybe there's something that we can use if only we had the way to bring people into the discussion that would certainly be, exceptionally beneficial, and also bring the groups closer together. Because once you collaborate and co-design something, you have much more of a vested interest in making and ensuring the success of that particular operation. So one of the things that, we need to really start with as an industry is think about how do we actually integrate a lot of our information. So, still as an industry, a lot of our information is somewhat siloed. So we have geological information, it might be connected to the mine planning information, it could be two completely different separate systems. We have then processing plant information, we have maintenance information, we might have ERP systems. So I think part of this process is actually looking at how do we bring together and allow people to visualize and understand across that whole value chain information. And I think that's where, there are some exceptionally powerful tools allowing us to have this integrated master data. As I said, one of the key issues then is to make sure that we have big data capabilities with the smallest amount of data possible. And I say this, as I said, not only because of the cost, and I know I recently spoke to one mining company who actually were doing some simulations and some great work, and genuinely trying to understand how changing particular components were going to drive change within their operations and optimize that change. But unfortunately, they were using a tremendous amount of data and trying to, I guess, understand patterns within that data. And unfortunately, someone had left the simulation running over the weekend. And because of that mistake, just the movement of these vast amounts of data and then running the sort of simulations in the background, caused a significant overrun of costs, in the order of $100,000 to $200,000. Now, I mean, I know that's just a mistake and these things happen, but I think if we're at least thoughtful about how do we use the least amount of data to get the best outcome, then I think certainly some of those challenges, those mistakes which will happen from time to time will at least be managed and manageable. But also, as I said, it's the additional burden of some of those sensors, etc., that are placed upon maintenance. Now, often then when maintenance can't maintain all of the sensors, they just don't have the manpower, or in some cases, maybe we don't set up the right maintenance regime for all of those sensors. They will make decisions about what are the most important sensors, or sometimes it might even just be that they make decisions about sensors that are constantly breaking. Now that could be that they're in the wrong place, it could be all sorts of different reasons, but these could be some of the most important ones that you have. So I think, it's very important to minimize the number so that the ones that we actually have are the important ones, are giving us data and information, not only so that we then calibrate them, we identify when they're out of calibration or they're giving weird or, even true information that takes us, means that we have to act, but also so that, I think the credibility of that data can be continuously maintained. And, again, I know in my own experience, we have, when people think that the information is not looked at or not important, then just out of necessity sometimes they will deprioritize either responding to that information or to maintaining those particular sensors. And, it certainly wouldn't be the first time that I've seen a pH sensor showing 16, which, unless we're on Mars or we change the laws of physics, as we all know, is not possible. So I think it's a very important part for us to consider. And then, I think I've spoken a lot about simulations, and I think for me, simulations are just fundamentally important to us rapidly changing the mining industry and really understanding the consequence of our decisions. The particular one I'm going to show you at the moment was one that was developed for a company wanting to look at building a dam in a particular place and what the consequences would be should that dam fail, under what conditions would it fail, and so that they could not only prevent the failure, but also if the worst happens, know that that failure would lead to limited consequences, or at least the least possible consequences. So this one actually does have a music in the background, so I'll be quiet while it plays. So of course the benefit of this particular simulation, and this is only the beginning of the simulation, of course then you can build buildings or cities or towns or other infrastructure, could be you know, power lines if you happen to have it, but you could build a series of infrastructure and establish again, you know, the sorts of consequence of failure of this particular dam. You've clearly got the forces, the force profile, and so, you know, you can really understand the difference between different designs, between different positionings of the dam. You could potentially look at, you know, relocation of other infrastructure, etc. But again, you know, using these sorts of approaches to first try in a virtual world before having to do it in the real world, and again increasing the confidence that boards or communities might have in this new structure that might be going in. So again, you know, one of the things that we've worked with a number of customers on is just how do you present some of those simulations? How do you design them? So, you know, it could be a caving simulation, it could be an in-situ leaching simulation, or virtual twin, sorry, not just simulation, broader than that. It could be a, you know, a mine, a new processing plant. But how do you design that virtual twin? And then how do you use the results of that to present to boards, to governments, to investors, to communities, so that they can thoroughly understand the consequences of the suggested new approach, innovation, new design, new mine, whatever it might be. Now, one of the interesting things that you know, we're seeing is that the more that we enable this transformation in the mining industry, the more we undergo a digital transformation, the more that people are actually important. Because I say this often because I think one of the pieces of feedback that I've been given is that people are really questioning, you know, is this transformation going to make people irrelevant? Are we going to have less people in the industry? Will we have you know, computers doing the work of geologists? Will we have, you know, people completely replaced? And, you know, for me, I think the whole purpose of what we are trying to do is to augment human capability, to make it easier for people to make decisions, to make the correct and faster decisions, take away some of the work that might be mundane, repetitive, unsafe, maybe give people insights that they couldn't have had just because they don't have the time or even the ability to do the calculations, yet can make fantastic decisions when those insights are given. And certainly that's what we're seeing. We're seeing that, in fact, people become more important, that the jobs may be shifting, they may be retraining, they may be even shifting in location, not even just style or type of jobs. But in fact, people are still are fundamentally important to the mining industry. And in fact, some of those people's skills become even more important. So, you know, people's ability to communicate, to collaborate, to work in teams, to identify issues, to help drive change and behavioural changes are becoming significantly more important within our industry. So what does this mean in terms of a mine virtual twin? So here I just wanted to give you an example of a mock-up that we did looking at a simulation, a mine simulation, and comparing that to the real world and integrating the two. So first we have the simulation. So here's the predictions placed by the computer. How will this function? What can it do? What's the capabilities of the equipment? How does that model out in terms of the plan? And then we have some real footage, the actuals feeding into those plans. and combining the two. So the simulation and the plan going into the real world, and the real world data coming back into the plan. So again, as I said, I think one of the keys is that these skills are changing radically within our industry. People skills are becoming more important. Those sort of new skills to meet these new challenges. Some are the ones we've been speaking about for some time: data science, HV electrical, you know, etc. But there's some really interesting new ones in instrument technology, which we've been speaking for some time. But interesting new ones, you know, around collaboration, communication, humanistic design. I think a huge one. You know, it's not just using agile techniques. Now we need to really think about how we design for people, how we design to make things easy to use, alluring, make it easier for people to do their job. Ethics, just because we can do something, should we? And you know, what are the sorts of biases that we're building into some of the technologies or the solutions? And as I said, you know, as we start integrating technology and bringing technology into the mining industry, connecting it across the value chain, giving people these tools to create these twins, so are we making it easier for people to, or we should be doing, is making it easier for people to do their work and really augmenting human capabilities. So we're building solutions to be better. Sorry, we're not building solutions to be better than humans, but in fact, what we should be doing is to make human experience better. So I'd like to thank you for listening. If there are any questions or queries, please feel free to contact me, either reach out via LinkedIn or directly email me. And I hope that you thoroughly enjoy the rest of the CIIT program. I know that I've really enjoyed speaking to some of you that I've already spoken with and looking forward to speaking to others over the next few days and listening to a number of the presentations. So thank you very, very much.